Alright, so now we have expressions that have what we call non-permissible values, as in numbers that just won't work. Why is this new? Well, in polynomials, you've got addition, you've got subtraction, you've got multiplication, that's all fine, but when we get into rational expressions like this, the new thing is that we're now dividing. This expression is 12x squared divided by 2x. This one is the numerator divided by a plus 7, a plus 1, and so on. And there is one of the things in math that we absolutely cannot do is divide by 0. We can't do it. We're not going to show you how to do it in 2 years either. We seriously can't. And so whenever you have an expression like this, you have to look at your denominator with the idea that if this, the denominator, the divisor, ever equals 0, we have a serious problem. So if 2x equals 0, in other words, that would be bad. We don't want that to happen. Divide both sides of that by 2, and you find if x is 0, that is bad. And so, for our non-permissible values, we say 0 is one of them. In this case, it's the only non-permissible value. If you try to plug 0 into this expression, you get 0 divided by 0, and we can't do that. Your calculator can't do it. It will not work. So when you give someone an expression like this, you also attach kind of like a warning label to it saying, hey, don't try to put 0 into this. It's not going to work. This is medium important if you're doing math with other people. It is critically important if you're doing any kind of computer programming, because if you tell a computer to try to divide by 0, it will try and then it will crash. Your program will lock up or throw an error message of some sort, and if that isn't handled correctly, if your computer locks up, sometimes what's happened is the program has tried to divide by 0 and it wasn't able to, and bang, instantly the program stops. So people usually don't panic when they get a division by 0, but either way, we're going to attach these warnings from now on saying, hey, here's a number that you don't want to try. With expression b, we're thinking we take the whole denominator, a plus 7, a plus 1 equals 0, and we're saying this would be bad. If that denominator goes to 0, then we get division by 0, which we can't handle. Now, if you've taken the polynomials unit, you know how we handle this. This is the zero product theorem again. We can take these separately and say either a plus 7 equals 0 or a plus 1 equaling 0. Either one of those would be bad. And so, solve each of these separately. If a is minus 7, that's bad. Or if a is negative 1, that's bad. Those are our two non-permissible values. When it depends on the person how they express these. Some people give these as a list and say the non-permissible values are a is negative 7 or a is negative 1. Others will say, they'll put a not equals here. They'll say what you should be putting on your function is a must never be negative 7 or a must never be negative 1. These both make sense, even though they seem to be contradictory in the fact that one has an equals and one has not equals. So you have to adjust for the person that you're talking to and just judge, do they expect you to say equals, as in these here are the numbers that you don't want to use, or do they want you to use the not equals symbol? There kind of isn't a standard way of doing that. Here, y squared minus y minus 20. So we're saying if this equaled 0, that would be a bad thing. We'd get division by 0 then. So how do we solve this? Well, it's a quadratic, which means it should be factorable. It should be possible to find a couple of numbers that add up to negative 1 and multiply to negative 20. Oh, look, I just did. And now if you solve these separately, you get either y equal 5, that would be a bad thing, or y equals negative 4 would be bad as well. So those are your non-permissible values. Right? It never has anything to do with the numerator. It's all about the denominator, because that's what you're dividing by. So this equation is whatever, who cares, divided by x squared minus 49. So we're saying if x squared minus 49 equals 0, that would be trouble. When does that happen? You can factor this as a difference of squares, and you'll get x plus 7, x minus 7, or you can take the 49 over to the other side. I'm not necessarily promoting this way, I'm just doing it to show you that it works. Root both sides, and you get x is plus or minus 7. So x equals negative 7 would be a bad thing, and x equals positive 7 is bad as well. Those are our non-permissible values.